Hi, this video is going to be about gradient. So first off, gradient and slope are two interchangeable words. So your textbook will be more likely to rely on gradient, but gradient and slope either, they mean exactly the same thing. So as you can see on the screen, gradient is a measure of the steepness of a line. So when you have a line graphed, you can look at that and say, gee, that's steep, or that's not as steep as the other one. But the gradient is an actual numerical value to distinguish, the steepness of a line. So gradient is a fraction, usually, can be a whole number. It's always reduced to lowest term. So if it can be reduced to a whole number, it will be, but it will never be made into a decimal. So that's really important. So fraction, lowest terms, may or may not end up being a whole number. And it's made up of two numbers, the vertical step of a line and the horizontal step. So what does that mean? Okay, so you have a line and you arbitrarily pick 2 points on that line and you determine the horizontal step. How far have you moved horizontally to get from one point to the other? And then the vertical step. How far have you moved vertically to get from one point to the other? So then you take those two numbers and you plop them into a fraction, you reduce it to lowest terms, and away you go. Because it's a straight line made up of an infinite number of points, it doesn't matter which 2 points you pick. If it's a straight line, the steepness is not going to change whether you choose 2 points that are really close together or 2 points that are really far apart, or you choose points down here or points up there. It doesn't matter because it's a straight line. Any 2 points will give you the same answer for your slope. Okay, so let's look at the two lines below and let's actually figure out what the slope of these two lines are. So when you have a line that's graphed on graph paper, it is by far in your best interest to pick points that actually exist in corners, because then you're counting whole numbers and not trying to estimate in between the lines on your graph paper. So let's take beginning to end. So if we start here and we go to the other end, then our first step is going to be to figure out horizontal step from here to here, vertical step from there to there. And the vertical step is already indicated to us, which is 6. So for line 1, the vertical over horizontal is going to equal 6 for the vertical, and then the horizontal is 1, 2, 3. So 6 over 3, and we reduce that when and if we can. So line 1 has a slope of 2. Great. So now let's go to line 2. So again, the vertical step is already indicated for us at 7. So we have line 2, vertical step over horizontal step, that equals 7. And then our horizontal step is equal to 1, 2, 3, 4. So we have a fraction of 7 over 4. So if you're looking to figure out which line is actually steeper, you have to figure out which number is larger. The larger the number, the steeper the line. So if we were to actually figure that out as a fraction, we would get 1.75. We would never do this. This is purely for comparison's sake. We would leave the two slopes as fractions. Well, actually, I guess over here. We would leave it as the 2, and we would leave it as 7 over 4 because that's reduced as far as it can go. For comparison's sake, line 2 has a slope of 1.75, line 1 has a slope of 2, therefore line 1 is the steeper of the two because its slope is greater. Bigger slope, steeper line. All right, so you can have lines that go up as you read them left to right. So similar to reading the English language, which you read from left to right, we read lines from left to right. So if the line goes up as you read it left to right, then that has a positive gradient. So the horizontal step is positive, the vertical step is positive, so you end up with a positive number over a positive number, which means your overall fraction is going to be positive. You can also think about it as if you owned a business and you saw that your profits went like this. That's a positive thing, right? So as it's going up left to right, that's positive. So that slope will have a positive, that slope will be positive. On the contrary, if you have a line that you read left to right and it goes down as you read it left to right, that will have a negative gradient. The horizontal step will still be positive, however, the vertical step will be negative. So what you end up with is a negative vertical slope over a positive horizontal slope. So negative divided by positive means overall that slope is going to be negative. Again, if you own a business and somebody brings you your profits and they start to look like that, that's a negative thing. So that's another way of remembering it. You need a bit of a way of remembering it. You can always work it out and calculate it, but you need to make sure that you're reading these lines left to right. That's really key. Okay, so let's talk about horizontal and vertical lines. So it's all fine and good for a line to be going up as you read it from left to right, but what if it doesn't go up or down? So what if it is completely horizontal? Or what if it doesn't actually go left to right and it is completely vertical? So these are two special cases, and as you can see in the notes written on the top, you already know what the answer is. So a horizontal line, if you have a vertical step over a horizontal step, and you pick 2 points on your line, and you have made no vertical step at all, but you only have a horizontal step. So you have a vertical step of 0, and then you have whatever it is on the bottom, let's say a horizontal step of 5, but it doesn't matter what it is because 0 divided by anything is going to give you an answer of 0. So for a horizontal line, the slope is 0. The gradient or slope of a horizontal line is 0. On the contrary, if we do vertical step over horizontal step for a vertical line, and you arbitrarily pick 2 points on the vertical line, let's imagine you have a vertical step of 3. It doesn't matter what it is. You have a horizontal step of 0. If you get a calculator out and you do 3 divided by 0, you end up with an error message because you cannot divide something by 0. You can't divide something into 0 parts. So this gives you what is known as an undefined slope. It is undefined because you cannot actually divide by 0. So you need a bit of a way of remembering this, and this is one of my favorite things to teach in grade 8 math. So if you were skiing, downhill skiing, so let's imagine you are downhill skiing and you are downhill skiing on a completely horizontal ski slope. So imagine you're at the chalet and you have to make it all the way across the bottom of the hill to get to the chairlift. No slope whatsoever. Horizontal slope. That is 0 fun. It is no fun to strap on some downhill skis and ski horizontally. No fun at all. On the contrary, if you were to ski down a completely vertical slope, we're going to call that an undefined amount of fun because it is unclear if you will live or if you will die. So we're not sure, so we're going to leave that as undefined. So skiing completely vertical slope, undefined amount of fun. Skiing completely horizontal slope, 0 fun. All right, so let's put this into practice. Let's actually find the gradient of this segment of the line from A to B. So we need to know the horizontal step. We need to know the vertical step. So we've got vertical step over horizontal step. My vertical step going from here is 0, 1, 2. So my vertical step is 2. Horizontal step is 3. So I cannot reduce that anymore. So the slope of AB is 2 over 3. BC, on the other hand, we're going, let's change colors. So we're going from here to, get this all lined up again. Perfect. Okay, so let's erase these little marks. So we are going from B down to where C is. So we're going vertically down, or I guess you could do either way, and then we're going horizontally that way. So my vertical step is -1. Vertical over horizontal. So I've got -1, and my horizontal step is 1, 2, 3, 4. So -1 over 4. Again, reduce when and if you can, but you can't in this case. So we've got 2 over 3 for line segment AB, -1 over 4 for line segment BC. Okay, let's look at a different kind of question. This one is draw a line that goes through a particular point with a particular gradient. So we're given our particular point of 1, 1, and we're given a particular gradient of 2, 3. So the first thing I'm going to draw is my set of axes. Then, if I know that my line has to go through point 1, 1, I'm going to start by putting that point in place. So I've got point 1, 1 in place. Now, to figure out where to go now, you need to understand what this fraction is telling me. It's telling me that to get from one point to another, I'm going to go 2 vertically, and I'm going to go 3 horizontally. So from the point that I was given, 1, 1, I am going to count up 2, vertically 2, and then horizontally 3. And that is the next point on my line. I could do it again if I wanted to, right? Up 2, over 3, and I will get the next point on my line. And so then you connect your dots with a ruler, arrows on both ends to show that it is a line. Line goes on forever in both directions, and it goes through the given point that I was assigned. Okay, so what if you don't have graph paper? What if you can't draw the line? What if you can't count the spaces? There's got to be a way, right? You're right, there is, in fact. So we have a formula. Now, you will always be given formulas. You don't need to memorize them. You probably will memorize this one because you're going to use it so much, but you don't have to. It will always be given. But it is still the vertical step over the horizontal step. So vertical is denoted by y, my y coordinates. Horizontal step is denoted by my x coordinates. So every point has an x coordinate and it has a y coordinate. We talked about that in the beginning of this unit. Every set of coordinates, every ordered pair has an x and a y. So this is point 1, the x coordinate of point 1, the y coordinate of point 1, and then we have point 2. The x coordinate of point 2, the y coordinate of point 2. So x1, y1, x2, y2. If you know the coordinates of your 2 points, you can use this formula, which you just plug your numbers into and figure out the gradient without having to graph the line. So if we look at the example below, find the gradient for point P, which is 1, 3, and Q, which is 4, -2. So the first thing you need to do is you need to assign arbitrarily one of them to be point 1 and one of them to be point 2. It does not matter which you make point 1 and which you make point 2. You will get the same answer if you do it correctly. So then, if this is going to be point 1, then 1 is the x coordinate of point 1. 3 is the y coordinate of point 1. 4 is the x coordinate of point 2. -2 is the y coordinate of point 2. And then once you have that labeled, away you go with the formula. y2 minus y1 over x2 minus x1. Then you plug in your values. Okay, so y2 is -2 minus y1, which is 3. x2 is 4 minus x1, which is 1. And then you do some integer work. -2 minus 3 gives me, let's move over here, -5. 4 minus 1 gives me 3. So the final answer for my slope is negative 5 over 3. I can't reduce that. I can't do anything else with it. That is the slope of the line that would connect those 2 points. Okay, so that takes us through 2 ways to figure out gradient. So you can figure out gradient by counting vertical step over horizontal step like we did here. So if you have the line graphed, great, way you go, count away. Vertical step, horizontal step. If you only have coordinates and don't want to go through the trouble of graphing it all out and then figuring it out, you can use the formula by assigning x1, y1, x2, y2 to your 2 points and then working them through the formula. Okay, that's it. Thanks so much.